Hello guys, welcome back to my channel. In the previous videos we have discussed the principal theory, instrumentation of spectroscopy, have discussed different types of ionization techniques, right? In today's class we will start from analyzer of quadrupole and time of flight. Okay, I think so you are able to understand my videos. We will recall what all we have studied, okay, in this video. Firstly, we have studied the important questions which are present in the mass spectroscopy. Okay, then we have studied uh, the basic concept, and we have studied the principle involved in the mass spectroscopy, principle involved. Okay, then we have studied the theory involved in mass spectroscopy, right? I hope you understood the theory. And we have also started the instrumentation. This is the instrumentation, and we have discussed the six type of instrument types. I mean six type, not the types, six parts of instrumentation: sample, inlet, ionization source, and ionization technique, soft ionization, and hard ionization. We have discussed it, and ionization methods we have listed it out, and clearly explained in the previous video. This is electron impact ionization, okay, and the chemical ionization, field deposition, which is not much important, and the very important one, atomic absorption bombardment, it is also called as fab. We have also we have discussed this, and we have discussed with MALDI, which is very similar with fab, only here the laser is present rather than the inert gas. Okay, and we have also discussed the other three types. If you learn 5, that's more than enough. If you want to learn, you can refer other videos. Now we will start with the important one, the next part of instrumentation. See, here we have discussed the sample, inlet, ionization source, ionization. Now acceleration, deflection, and detection. Okay, see acceleration, how the acceleration process is going on. The ions are accelerated so that they all have the same kinetic energy. Here every ion should have the same kinetic energy, okay, and it should reach the detector. So we use three chambers, 1 2 3 chambers, okay, or the plates. We use three plates, okay. First plate has 10,000 voltage, second place has between 10,000 to 0 voltage, I mean like off of it, or between 10,000 to 0, and the final voltage is 0, the final plate voltage is 0. Okay, here when the positive ion comes, right, it is positive, and the field is produced also same positive. Due to the positive nature, it repels. Okay, it repels in the direction, if it has positive charge, all ions will be positive charge, and it repels with the magnetic field generated, with the positive magnetic field generated by this by these plates. Okay, it will accelerate with very fast, it moves very fast in it. Okay, by end of the plate, it will be have same voltage. If here is ion is coming present, right, it moves faster, and here it reduces, and here what happens, right, it moves, it still reduces, the speed still reduces. Okay, the first plate will be higher because higher voltage, second medium voltage, and third zero voltage. By this we will control the flow of the ions. Okay, uniform flow of the ions will be getting. Okay, as we are decreasing here, higher voltage will be here, higher repulsion, and here low, no repulsion will be there, right? When they reach the third slit, right, they all will be have same acceleration or the speed. Okay, see here, the positive ions are repelled away from the positive ionization chamber and passes through three slits with voltage of decreasing order. Okay, the first slit has the highest voltage, and the middle slit carries intermediate voltage, and final at zero voltage. What I have said, right? The first slit has highest voltage, second it is an intermediate voltage, and the final has zero voltage. All the ions are accelerated into a finely focused beam. Okay, this is the process of acceleration. Next, deflection. The ions are then deflected by a magnetic field according to their masses. Okay, the lighter they are, the more they are deflected. See, if the deflection of lighter molecule is very easy than the heavier molecule. Heavier molecule require more energy or more field. Okay, so lighter molecules, as they are lighter, they get more deflected. The amount of deflected also depends upon the number of positive charges on the ions. The more the ions is charged, the more the deflection. As it is also the same concept, as the charges increases. If the charge is like +3 +4, it gets more deflected. Okay, because mass is decreasing, right? Electrons are going, the mass is decreasing, so that the charge, if charge increases, then the deflection is also increases. If the weight decreases, they get more deflected. That's the correlation. After deflection, they will reach to the detector. The beam of ions, see, the beam of ions passing through the mass analyzer is detected on the basis of mass to charge ratio. When an ion hits the metal box, charge is neutralized by an electron jumping from the metal onto the ion. See here, the how the detector detects, right? Example, this ion, the positive ion, it's the metal detector. This is the metal detector. It's the metal detector. Here, due to this positive nature, an electron is released. Sorry, electron is released to neutralize this positive charge. Okay, how much amount of electron is released to the positive charge, right? How much amount is released? By this, we will calculate the mass, or will analyze the sample. This is the concept behind the detector. If the negative charge is released more, okay, the change in the change in current after releasing the electron from the metal ion to neutralize the positive charge completely, right? Then we will calculate how much charge or how much energy is required to neutralize the positive charge. It is directly proportional. If it require more electrons, then its mass is higher. If it require low, then its mass is low. By this way, we will analyze. Okay. Next, before reaching the detector, quadrupole analyzers, we will arrange the ions according to their masses. Okay, we will maybe you're seeing the diagram now. I have not drawn the diagram. Maybe you're seeing this diagram, right? I will paste it here and minimize it, paste it here. Okay, see, the diagram contains four rods. Okay, the opposite rods have same polarity. It has four rods that are electrodes with electric field around them. Okay, uh, electrodes have both DC and AC voltage applied on them. The four electrodes contain both DC and AC voltage applied to them. Okay, each pair of a rod has exactly the same voltage as the one direction opposite. Okay, see, the opposite rods have the same voltage. Okay, I'll explain. See here I have drawn a rough diagram. I'll explain this. Then you can draw the actual diagram which I'm showing it. Okay. See, this is the source inlet. This is a box. Okay, this is a box present in a box. Okay, this is a source inlet. From here the ions fragmented ions pass through this. Okay, it contains 4 rods. 1 2 3 4. Okay, 1 2 3 4 rods. Okay, these 2 rods contain the same voltage, I mean same current or same polarity. See, each rod has exactly the same voltage as the one directly opposite. See, this and this one has same exactly the same voltage, and this one has this two has same voltage. See, these two are connected through one wire, and these two are connected through one wire. Okay, both AC and DC passes alternatively with in it, and from in between the ions are passed, and here they reaches out to the detector. Okay, I think so understood. You just read this. See, it has 4 rods that are sorry, it has 4 rods that are electrodes with electric field around them. Electric field is present around them. Okay, uh, electrodes have both DC and AC voltage applied to them. Okay, each pair of rod has exactly the same voltage as the one direct opposite. Okay, each has the same voltage which is opposite side. Depending upon the ratio of DC and AC, ions acquire affinity by the magnetic field. See, depending upon the AC and DC ratio, ions acquire the ions are affected by the magnetic field. Sorry, my mistake. Ions are affected by the magnetic field. Okay, this point will make you understand. Ions of correct mass to charge ratio does not collide with the rods and travel to the detector, and others with loss or high have made mistake low or high mass to charge ratio are unstable and does not pass. See, if the ion has particular mass to charge ratio, the fixed ratio, then it passes through the exit slit and moves to the detector. If it has more or less, it collides with the detectors and it does not pass through the collides with the rods and does not pass through the detector. Okay, this is the mechanism of quadrupole mass analyzer. I'll show you the diagram. You can pause the video and draw the diagram. Okay. See, if the DC is positive, higher mass ions will have stable path. If DC is negative, lower mass ions will have a stable path. See, if you want to take only the large mass ions, if you want to analyze the large mass ions, then the DC should be positive. If you want to analyze the lower mass ions, then the DC should be negative. This way, alternatively also it works. Okay, by this way we can analyze the sample. Next, the important one, time of flight. These both are very important. Okay, time of flight, this is very simple. In this type of analyzer, sorting of ions is done in an absence of magnetic field. Ions produced are acquiring different velocities depending upon their masses. See, based upon the masses, the velocities they acquire. Here the particles reach the detector in order of increasing of their masses. Here electron multiplier detector is used. The resolution power of this is 500 to 600. Okay, see, understand the principle. It's very easy. Sample inlet, it is done in a vacuum chamber. Ionization area, acceleration area, and time of flight. See here, when it moves through the analyzer, right, where this is the time measurement. If the particles has heavier mass, it moves downward. okay, then reaches the detector. If it is a lighter mass, it's upward. See here, the velocity of ions depends upon the mass to charge ratio. The time that is subsequently takes for the ion to reach the detector uh, uh, at a known distance is measured. See, from here to here, how much that ions time is taken to reach the detector is analyzed, and by this measurement, the time, by measuring the time, we will analyze the ions. This very simple. This time will depends on the velocity of ions, and therefore is a measure of its mass to charge ratio. By using the time taken to travel from here, time taken travel to from here to here is measured. If it is lighter molecules, it moves faster. If it is heavier molecules, it moves slower. Okay, by this way we will detect. See, the detectors are Friday's cup, electron multiplier, and photomultiplier. In the next video, we'll start the fragmentation. We'll start fragmentation. Today's video will end from here. Thank you guys. See you in the next video. Bye.